Color theory gives us a look at how colors work together, where they come from, and especially the difference between additive and subtractive colors. It is really key for you as designers, video editors, producers to have a sense of how color will work in a deliberate way. So let's take a look at this. Color theory has been around for a very long time. Think about old stained glass from the medieval times. We have thought about color in our world for quite a long time. And while often we pick colors because we just happen to like them, the blue in our video room is actually just because I thought it was a neat color. Our goal is to be deliberate and help people respond in different ways. So a very warm tone may be very calming and very soothing. A cooler tone, something blue, may do something else for a viewer. So colors aren't just what's prettier and what's nice, but in design, it's about being deliberate. All right, additive color. Anything that emits light, so projectors, your phone screen, your computer screen, the sun, uses the additive method of creating color. Additive color is made up of red, green, and blue. When we say RGB colors, that's what we're talking about. Red, green, blue, mixing those so that in some way we are creating colors. When we are talking about print, not screens, then we're talking about subtractive color. So if you're working in Illustrator and you're working for print or InDesign, then you are using subtractive color. The subtractive method of color is used for anything that reflects light rather than projects light. Anything printed. So we're now using a blend of C, M, Y, and K, which is key. So let's run through this. C for cyan, M for magenta, Y for yellow, and K for key, which is essentially black. Not exactly, but essentially. Color is determined by the way a pigment reflects light. White is the absence of color, and black is a combination of color, and it's only formed using K. One of the things about subtractive and additive color, you will see literally thousands of color possibilities. They're all coded. There's a lot of different ways of getting them, whether it's swatches or palettes or the very simple old school Apple crayon palette. Whatever you're doing, though, you're using two different methods of color in a program like this. Additive for projectors, screens, anything that is projecting light, or subtractive when you're reflecting light, printed matter. Color wheel allows us to see at a glance which colors are complementary, those opposite on the wheel, analogous, those that are adjacent, and triadic, three colors positioned at 120 degrees on the wheel from each other. So let's look at what might be considered complementary colors and pick any starting point on the outer wheel and look at the opposite. And you'll generally find that in some way these colors are complementary. Analogous colors, things that are side by side on the wheel. And triadic, if you start with one color and then move out to 120 degrees, not quite, a little past the 9. So if you're starting with the top purple, then you're down into that dark green. And that triadic is sort of laid out for you in this inner section. You can look at the purple top and the green on the right and the orange on the left and then the yellow. So that's considered triadic. The color wheel can be really helpful for picking colors that go together in a design so that you don't have kind of chaotic things. That said, color is very much a subjective thing, but being aware of a color wheel gives you kind of an edge in being able to put things together. There are three components to color, and they are hue, saturation, and brightness. Hue is where on the wheel we find that blend of a color. When you're working with Photoshop, Illustrator, even Premiere, you see hue, and it's really how deep a color we're going, what sort of the tint is of it, or the hue. Saturation is how rich a color is. The higher the saturation, up to 100%, that color is fully saturated. If you take a color and bring it all the way down to 0, then you have gray. Yellow at 0% brightness. Brightness is the last of these. Yellow at 0% brightness is black, and at 100% it is full yellow. That's one example, but brightness is also something that can be adjusted for colors. So when we're talking about what are the three components of color, they are hue, saturation, and brightness. I should have highlighted brightness a little more, but I think you'll get that. The color gamut is where the range of colors that a system can produce. So if you're looking at Photoshop or some of these other programs, they use either CMYK or RGB to give you the full range of colors that are available for you. So that, in a nutshell, is color theory. If you are familiar with additive color, the subtractive method of color, with the components of color being hue, saturation, and brightness, and the basics covered in this, then you should be set to go. Please take a look at the color wheel, understand triadic colors, complementary, and colors that are kind of going together, analogous. Then you should be in good shape.